Hi, I'm Juvel Kalawalatian and this is my video presentation in fundamentals of mixed signals and sensors. And my topic is amplifiers. Okay, what is amplifier? An amplifier is an electronic device that increases the voltage, current, or power of a signal. Amplifiers are used in wireless communications and broadcasting, and in audio equipment of all kinds. They can be categorized as either weak signal amplifiers or power amplifiers. Here is the short video to understand more about on how does the amplifier works. This is I get in internet the video, example of the video.
A current of electrons, the battery's negative terminal, moves across the transistor through the loudspeaker to the positive terminal. When a sound wave pushes the microphone diaphragm in, a weak signal of a few electrons flows into the microphone. This leaves a lot of holes in the base. Now, many electrons from the emitter can flow through the base and into the collector. A strong current flows to the loudspeaker. When the microphone diaphragm moves up, the electron flow reverses. Electrons flow from the microphone into the base. Here, they fill up the electron holes and block the flow of electrons from the emitter to the base. No current flows.
Okay. Okay, and the transistor is a semiconductor device used to amplify or switch electrical signals and powers. The transistor is one of the basic building blocks of modern electronics. The types of bipolar junctions transition and transistor. PNP bipolar junction transistor and NPN bipolar junction transistor. The field effect transistor. The field effect transistor used in many circuits constructed from discrete electronic components in areas for RF technology to power control and electronic switching. The source through which the carriers enter the channel. Conventionally, current entering the channel as S is designated by IS. Drain is through which the carriers leave the channel. Conventionally, current entering the channel at D is designated by ID. Drain to source voltage is VDS. The gate, the terminal that modulates the channel conductivity by applying voltage to G. One can control ID. Junction for field effect transistor. Circuit symbol, gate, drain, and source. That is the P channel, and the drain, gate, source, N channel. The difference. Okay. And the bipolar junction transistor is a three-terminal semiconductor device that consists of two PN junction which are able to amplify or magnify a signal. It is a current-controlled device. In PNP BJT, the N-type semiconductor is sandwiched between the two P-type semiconductors. The two P-type semiconductors act as emitter and collector respectively, while the N-type semiconductor acts base. This is the emitter-based collector. below. The emitter, the P, and the base is the N, and collector is the P. In NPN, BJT, P-type semiconductor is switch between the two N-type semiconductors. The two N-type semiconductors act as emitter and collector respectively, while the P-type semiconductors acts as a base. This is the emitter, base, and collector. Sorry. The next is the types of amplifier classes. This class amplifiers are the most common type of amplifiers topology, as they use just one output switching transistor, bipolar, FET, IGBT, FET, IGBT, etc. within their amplifier design. And class amplifiers, they were invented as a solution to the efficiency and heating problems associated with the previous. And the class AB amplifiers is a combination of the class A and the class B type amplifiers. We have looked above. The AB classification of amplifier is currently one of the most common used types of audio power amplifier design. The VCC, VOUT, and OV out, and OV. Operating curve, unused area, output signal, input signal. And the class C amplifier is designed as the greatest efficiency but the poorest linearity of the classes of amplifiers mentioned here. The previous classes A, B, and AB are considered linear amplifiers, as the output signal, amplitude, and phase are linearly, and phase are related to the input signal's amplitude and phase. This is the parallel resonance circuits, operating curve, unused area. As you can see in the input, it is the general amplifier model, input and output. Amplifier gain is a multiplier that exists between the circuit's input and output. Okay, if we have a gain of 100 and we have 1 unit input, then the output will be 100 units under the normal operating conditions. Input impedance is a loss of the amplifier presence to its signal sources. Output impedance is the source resistance that the amplifier presents to its load. And the gain as a ratio, often called ordinary gain. Gain is a traditional defined as a ratio of a circuit's output to its corresponding input. The current and power gain, they are also defined as below. Okay. Input impedance. When the amplifier is connected to the signal source and source sees the input impedance as its load. In our example, this value is 1.5 k ohms. This means that the signal source in the series which Rs and Zn. The voltage we define as Vn is a voltage that the amplifier actually sees. This voltage appears across Zin. The input circuit is actually as a simple voltage divider. The voltage of Vn is a portion of the input voltage and is given. given. And the next is the output impedance, Z out. When the load is connected to the amplifier acts as a source for that load. As with any source, there is a measurable value of source resistance. This is the output impedance of the amplifier. If the C out is 200 ohms, then the load sees the amplifier, a voltage source with the internal resistance of 200 ohms. The output circuit is a simple voltage divider. The value of VL is a portion of the output voltage and it's given. And the combined effects of the input and output circuit. The combined effect of both in the input and voltage circuit can significantly reduce the effective gain of an amplifier. Consider this circuit. And the next one is the input and output circuit has reduced the gain from 340 to an effective value of 276. Generally, we want the effective value to be as high as possible or be as close to 340 as possible. In our example, we can accomplish this by increasing the value of Z in, decreasing the value of Z out. And this is the example. We are essentially using the same circuit as before, only Z in and Z out have changed. Z in is much higher and the Z out is much lower. This is the example. As you can see, the effective gain has increased significantly by increasing the value of Z in and reducing the value of Z out. And that is, thank you.